If we look at this problem right here, and we find our information that we have for our x-intercepts and our vertical asymptotes, we end up with this interesting situation. So on top, if we have our x-intercepts, I would get that they are at -4 and +3, because I set the top equal to 0 to find our x-intercepts. For the vertical asymptotes, we set the bottom equal to 0 and we solve, so I get x equals -7 and +3. Okay? So now if we were to go graph this, right, we would have an x-intercept 1, 2, 3, 4, and at 1, 2, 3, and then if I graph our vertical asymptotes, we're at -7, 1, 2, 3, 4, 5, 6, 7, and at +3, and then we have this weird moment where I have a vertical asymptote and an x-intercept, right? This is weird because you're never allowed to cross an a vertical asymptote, but we have an x-intercept there. So what happens is it comes from this part right here where we've got the same factor on top and bottom. So if you ever end up with a scenario where you have an x-intercept and a vertical asymptote at the same spot, that means you missed a common factor. So what happens instead of being a vertical asymptote or an x-intercept is that reduces down to a hole or a lack of a point. So when we have a common factor, we end up getting a hole in the graph. Okay? So the hole, the x value of the hole is from the factor that's reduced. So in this case up here, we would have the x value of the hole would be the 3, right? Then the y value of the hole would be coming from what the reduced fraction is. Okay, so if we reduce this fraction, those reduce to 1, so I get x plus 4 over x plus 7. Okay, so what I would do, I use this to represent reduce, so f reduced of x, is I would plug this 3 into here. So if I plug the 3 into there, then I'm finding f reduced of 3, and that gives us 3 plus 4 on top, which is 7, and 3 plus 7 on the bottom, which is 10. So then our lack of a point would be at 3/7. So instead of having a vertical asymptote or our x-intercept at 3, I now just have this hole at 3/7. So I have a lack of a point. So the way that we show a lack of a point is just with an open circle. Okay? That's how we find our piece of information about the hole. Okay? We do the rest the same way as normal. Okay? As we go through our next example, I'll tell you which ones are easier to get from the original and which are easier from the reduced, and which one it doesn't matter, and which ones you have to do from the reduced. So the very first thing I always do, instead of doing it step by step here and then finding an error here, I always, not an error, but if there's something in common for our x-intercepts and our vertical asymptotes, I factor the top and the bottom. So on top, there's a common 2, so I take out the 2, so I've got x squared plus 4x minus 21. So then I'm trying to multiply to -21, but add to 4. So I can use 7 and 3. 7 needs to be positive, 3 needs to be negative. I don't need to pay back a number, so then this turns into 2 times x plus 7 times x minus 3 over our denominator that we haven't figured out. On the bottom, I have a common x squared. So if I take out the x squared, we've got x squared minus 2x minus 3. So then I'm trying to multiply to -3 and add to -2, so I have -3 and +1. I don't need to pay back any values, so I've got x squared, x minus 3, x plus 1. Okay. So now I have this reduced, or this factored part of our equation. So I look, and I notice that we've got an x minus 3 on top and on bottom. So this can be factored or reduced down to 1. So immediately when I reduce this down, there's a couple of things that I'm going to do. I'm going to write that on my domain, we have x cannot equal and then that value, because it's still part of our domain restriction when we have that hole. So I still have where it can't equal 3 because I add the 3 to the other side. Then I'm also going to come down here to my hole and put 3 comma and then just leave it blank, and then when I get down there I'm going to finish the rest of it. Okay? So then I write my reduced equation, so that gives me 2 times x plus 7 over x squared x plus 1. Okay. So now from here, I can use the reduced equation for everything else, right? So then as long as I've got this domain restriction from the whole, I can get everything else from this reduced equation. Okay? So if we look at our domain restriction now from the rest of the denominator, we have that it can't equal 0 and it can't equal -1. My vertical asymptotes are x equals 0 and -1. Notice that our vertical asymptote at 3 dropped because that was our common factor, so it's no longer there. So in this case, your domain and your vertical asymptote don't match numbers all the time. Okay? We still have even and odd asymptotes, so the x equals 0 is even and -1 is odd because the squared was an even and the unsaid first power was an odd. Okay? If we check our horizontal asymptotes, this gives us that we've got 2x over x squared times x, right? It's really 2x over x squared times x, which is 2x over x cubed, which means the bottom is bigger, so then it's y equals 0. Okay? Now, your horizontal, your slant, or oblique will be the same regardless of if you get it from the reduced or if you get it from the original. So if you want to go back here and compare squared to fourth, fourth is bigger, so on the bottom, when the bottom is bigger, it's y equals 0. Okay? Or if it's easier to do your long or synthetic division from the original equation rather than multiplying these out and then trying to divide, that's something else that you can get from either one of those. Okay? Our x-intercepts still come from the top being set equal to 0, so I have to get this from the reduced. If I get it from before, I'll get an extra x-intercept. Okay. So our x-intercept is at -7. Remember, the 2 doesn't ever equal 0, so that doesn't impact our x-intercepts. It came from an unsaid first power, so then it's an odd and a crossing. Okay. And then we have our whole, so now I can plug in f reduced of 3. So if I plug in 3, I've got 2 times 3 plus 7 over 3 squared times 3 plus 1. So 3 plus 7 gives us 10. We have 2 times 10, which gives us 20. 3 squared is 9 times 3 plus 1. 3 plus 1 is 4. So then we have 9 times 4, which gives us 36. And then we can reduce that. So both of those have a common 4. 4 goes into 25 times. 4 goes into 36 9 times. So we get 5/9. My y-intercept, you have to get your y value of your whole from the reduced equation. The x value has to come from the original, the one that has the common factor. So you have part of each one here. The y-intercept will be the same regardless of if you do it from the reduced or you do it from the original. Okay, so if we look at the reduced, if I plug in 0 here, so you can do f reduced of 0 or you can do f of 0, both will give you the same thing. If we plug in 0 here, I get 2 times 7 over 0 times 0 squared times 1, which will be divide by 0, so that means there is none. Right? Or if you could look over here, we'd have -2 over 0, which is undefined, which means, again, that there is none. Okay? So now we're going to put this information on the graph. So we have our vertical asymptote at 0 and at -1. At 0, it's even. At -1, it's odd. We have our slant horizontal asymptote at y equals 0. So horizontal in this case, our x-intercept at -7. And it's crossing. And then we have a whole at 3 5/9. So there-ish, right? And you can use this whole to tell you where your graph is going to be, right? So since the whole is above our horizontal asymptote, that means near this whole, it's going to also be above, right? So I wouldn't come from here and then have a graph down here except for a point and then just have this lack of a point, okay? So now I can use that information to help me. Notice on this left side, I could have it where I've got it comes and it crosses and pulls back towards the asymptote, or it comes and it crosses and pulls back towards the asymptote. I have nothing in here to tell me any piece of information, whether it be up or down, But this lack of a point tells me that I've got this portion above the horizontal asymptote. So I'm going to have from above here, again, we go towards that hole, but we don't actually touch that hole, right? It like hops over it essentially. This is an even asymptote, so on the right side, it's coming from above, so that means on the left side, it's also coming from above. So I'm going to have this parabola U-ish shape thing in between these two vertical asymptotes. This asymptote is an odd asymptote, so if on the right side it's coming from the top, that means on the left side it's coming from the bottom. So then I'm going to start here, I'm going to come and I'm going to cross, and then I'll pull towards the asymptote. You do need to remember to keep in mind your y value of your hole for your range. In this case, I have a y value over here that is the same y value as our lack of a point here. So I still have that we have the entire range all the way down and all the way up, because this y value of 5/9 is covered over here. Okay. So our range is -infinity to infinity. Let's try this next one, except for I'm going to rewrite it down here. X cubed plus 2x squared minus 8x all over x squared plus x minus 6. Okay, so we're just going to start by factoring the top and the bottom. So if I look at the top, we've got a common x. So if I factor out the x, I've got x squared plus 2x minus 8. So here I need to multiply to -8 and add to 2. I'm going to use 4 and 2. I double check my signs. Oh, nope. I want to get to a positive 2, so I need the 4 to be positive, the 2 to be negative. So 4 times -2 is -8. 4 plus -2 is really 2. I don't need to pay back a number because my a value is an unsaid 1, so then we get x times x plus 4 times x minus 2. On the denominator, we need to multiply to -6, but add to 1. So we're going to use 3 and 2. I need a positive 1, so I need 3 to be positive and 2 to be negative. I double check my signs. 3 times -2 is -6. 3 plus -2 is really 1. So on the bottom, we've got x plus 3, x minus 2. So now that I have this factored, I can see that we have this common factor here of the x minus 2 that's going to reduce, right? So when this reduces to 1, I'm going to put that my whole. We find the whole by doing the opposite, or solving the x minus 2 essentially. So I'm going to do the opposite sign and then divide by whatever coefficient it is. So change that sign, divide by here. So positive 2 divided by 1, which is positive 2. Or you're thinking, so x minus 2 equal to 0, so I add 2. So x is 2. And then I'm going to add x cannot be 2 on my domain. So now I'm going to look at my reduced equation. So my reduced equation is x times x plus 4 over x plus 3. So I can get the rest of it from my reduced equation. There are some things you can go back and get from the original equation. So if I look at the rest of this, for my denominator, I set that not equal to 0, so we can't have -3 either. When I set the denominator equal to 0, that gives us our vertical asymptote, so x equals -3. It came from this first power that's unsaid, so it's odd. If I compare my powers, we've got on top an x times an x over an x, which is really x squared over x, right? So then I need to synthetically divide. So again, you can do two things. I can, or long divide I should say, I can go back here, and from this one I can long divide. Or I can distribute here on top and get that this is really x squared plus 4x over x plus 3. Well, if I do that, this I can use synthetic division. So instead of doing long division from over here, I'm going to do synthetic division with this, and I'll end up with the same answer either way I had done it. So we're going to change the sign from here to the outside, which gives us -3. I check my powers on top, squared 1, and I'm missing a none, so I have to put a 0. So then it's going to be 1, 4, 0. Bring down the 1. Then we do -3 times 1 gives us -3. And then we do 4 plus -3 is 1. And then we do -3 times 1 is -3. and then we add straight down, so then that gives us -3. Again, we're not caring about the remainder because we don't on our slant asymptotes. Remember, this will be slant or oblique since the top was a higher power. So then that gives us that our equation for our slant is y equals, it'll be 1 power lower than our squared, so 1x plus 1. Our x-intercept I get from the top, set equal to 0 of the reduced. If you do it from before reduced, you'll end up duplicating a spot where your whole actually is. So I do it from the reduced, so I get 0 and -4. I don't need parentheses. Both of them come from an unsaid first power, so they're both odd and cross. Okay. The whole, the y value of the whole has to come from the reduced. The x value of the whole comes from the common factor that you reduce. So if I plug in f reduced of 2, that gives me 2 times 2 plus 4 gives me 6 over 2 plus 3, which is 5, so I get 12/5. So my y value from the reduced is 12/5. Remember, your whole is a lack of a point. The y-intercept, you can do f of 0 or you can do f reduced of 0. They will give you the same thing. So if I plug 0 here, I get 0 times something, so just 0, and then 0 plus 3 is 3, so 0 over 3 is 0. Or if you look here, we'll get 0 over -6, which is 0. Either way, we get that the y-intercept is 0, which I should be anticipating because we had an x-intercept of 0. Anytime you have an x-intercept of 0, you have a y-intercept of 0. So I'm going to put the information on our graph first. So we've got a vertical asymptote at -3. And then we have our slant asymptote. Our y-intercept is 1, and then our slope is 1. All right, so it's going to follow those 3 points that I just made. Okay, so there's our slant or our oblique. I have our x-intercept, which is also our y-intercept of 0, and it's crossing. And then -4 is also crossing. And then our asymptote is odd. Okay. I have an x-intercept here, so it's going to be above our slant asymptote, pulling towards the vertical and the slant asymptote. Just going to pull towards that. This asymptote, vertical asymptote at -3, is odd, which means since on the left side it's coming from the top, on the right side it's going to be coming from the bottom. So I'm going to come from the bottom. Notice I also have this x-intercept / y-intercept. So I'm going to come from here, cross through there, and then just pull towards my slant asymptote. And then our range, notice we're going all the way up, and all the way down, all the way down, all the way up. So our range is -infinity to infinity. Or you could have all real numbers. So that's how you graph your rationals with wholes. So you factor the top and bottom, find your common factor, cancel that out. Make sure you put that as part of your domain restriction and then the x value of your whole. Everything else you can get from the reduced equation. That's the shortcut way to remember everything.